All right, so now we're going to go into lesson 3.3, which is on completing the square and specific applications that involve completing the square. Now, in short, completing the square is going to be what enables us to convert from general form to vertex form, or it's going to connect our two forms that represent the same overall quadratic function, but we need this connection to go back and forwards before we go into our next section, which is purely on the general form. So we've done a bunch of work with vertex form. We've broken apart the vertex form in terms of what it means transformational wise. But now what we want to do is see the connection it has to not only applications, but how we can go backwards and forwards between the general form and vertex form. Now, in example one here, what we're going to do is we're going to take something in vertex form, and we probably recognize it as this y equals ax minus p plus q on the outside. This is the specific function they've given us in this case. So in order to convert this into general form, we're just simply going to expand it. So when we expand this, here's what we're going to do. It's going to be y is equal to, and then on the bracketed term here, when we see that something is squared, or more specifically, the binomial is squared, it wouldn't be appropriate to go 2 squared to the, or x squared from here, and then 5 squared from here. We do not distribute this power when things are being added in the bracket. And that's further emphasized off in the bubble here. When we take a squared term or a squared binomial, what we're actually doing is taking that term and writing it out as a product of the exact same term. Now, again, we're not taking the individual terms and just squaring them. That's a no-go. Please do not do this. Please, 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 please. I know I'm going to see a couple people do this in the practice, but I don't want you doing this. We need to write out the same term 2 times and then expand it. All right, let's expand this one here. So the x plus 5, I'm going to write it out twice. It's going to be x plus 5 multiplied by x plus 5, and then minus 3. Now what we have to do is expand this x plus 5 times x plus 5. I'm going to use my Pepsi symbol that I like to use at the 10C level, where I go first term to the outside. So let's write these two terms first and foremost. It's y is equal to 2. I'm just going to keep that 2 out there for now because I'll multiply it in a second, but I want to keep it out there for now. It's going to be x times x, which is x squared, 5 times x, which is 5x. Now I have to do my next two terms, 5 times x, and then 5 times 5. So my next two terms are going to be 5 times x, which is 5x. My end terms are 5 times 5, which is plus 25. Close the bracket, minus the 3. Now, here's where we combine our like terms and we can multiply in the 2. Before I multiply in the 2, I'm actually going to do one more step. I'm going to combine my middle terms. So instead of 5x, 5x, I'm going to make it 10x when we add them together, plus 25, bracket minus 3. Now we can distribute the 2, and this is going to become y is equal to 2x squared plus 20x plus 50, or 2 times 25 minus 3. The very last step here would just be to convert those, or connect these two end terms, the constant terms here. So rather than it being 50 minus 3, what we could make this is 47. And I'll do that right in the line below. I'll try to make this as neat as possible. So this is equal to 2x squared plus 20x, and then plus 47. There we go. Now this is general form because remember, it's ax squared bx plus c, or the constant term on the end, and this is our expansion. Now we're going to talk about lots of that in lesson 3.2, but for now what we want to do is take things that look like this, or these polynomials that look like this, these quadratic functions of this kind, and convert them back into the vertex form. But we know that going in the forward direction is quite easy actually. Taking a vertex equation and putting it into general form, as we can see, just requires a bit of expansion and collecting the like terms. Now, here's where we're going to go into completing the square. It's actually quite a detailed overall step situation here, but don't be afraid of that. What we're going to do is we're going to walk through each of these steps, and then we're going to try a bunch of examples, and we're just going to show you that it's actually not too bad once you do a couple examples, and you kind of get the rhythm of it. Okay, first and foremost, we want to arrange the terms by y is equal to ax squared bx plus c, or in descending order. So what I'm going to do is I'm going to take this original trinomial here, or the quadratic function they gave us, and I'm going to rewrite it as y is equal to positive 5x squared, and we really don't need the 5 to be having a positive sign on it, minus 30x, and then plus 7 on the back end. Okay, perfect. So we've rearranged it in descending order. Step number 2, we're going to group the first two terms that contain x, and then bring the constant term outside of the brackets. So what that means is we're going to rewrite this as the following. I'm going to write it as y is equal to bracket 5x squared minus 30x, and then close that bracket and put 7 on the outside, because we're going to do something very, very specific with these first two terms. As you can see, you're probably already predicting they look like they share a common factor. Let's see if that's our next step here. Remove the coefficient of x squared and keep it outside of the front of the brackets here. So in our next step, we're going to go y is equal to, well, what is the common term that can be removed here? In this case, it's going to be the 5. So we're going to divide both 5 and 30 by 5. We remove it outside the brackets. I now write this as x squared 30 minus 5, or 30 divided by 5, is equal to negative 6. We're going to keep the x as is, and then we're going to close the bracket and keep the positive 7 on the very outside. All right, so we've removed the greatest common factor. Now, for our next step, our fourth step, we want to make a perfect square trinomial inside of those brackets that we've just created. Now, how do we do this? It's actually quite a nice method. We're going to take the middle term, whatever that is, divide it by 2, and then square it. Or you can think about it in the following way. We're going to take this negative 6, divide it by 2, and square it. The negative 6 is symbolic of the b value position. So to generalize this, we go b divided by 2 all squared. When we go b divided by 2 squared, in our situation, this is actually equal to negative 6 divided by 2 all squared, which is equal to negative 3 squared, which then outside of here, we're going to put positive 9. Now, there's a reason that I'm keeping the negative in there, and that we're associating that negative that is in the middle here, or in the middle of the bracket, in the middle of the binomial, in here and in here. Now, something I'm going to get you to do throughout all our lesson notes here is I want you to highlight this one. When you take the b and divide it by 2, just before you square it, highlight that number, because it's actually really important and it comes up later on. Now, this positive 9, what we're going to do with this is we're going to rewrite our given function that we had above in the previous step, but now we're going to substitute this 9 in such that we can create a perfect square trinomial. Here's what it's going to look like. Y is equal to, our term on the outside was 5. On the inside, it was x squared minus 6x. We're going to put positive 9 first, then a negative 9. So we put the plus version of that number, the minus version of that b divided by 2 squared, close the bracket, put positive 7 on the outside. Now, let's just make sure we've taken all of the steps here, add it and subtract it in the brackets. Okay, so that's exactly what we've done here. We've taken the plus 9 minus 9 in that specific order. Now we move on to the next piece, which says move the fourth term outside of the brackets. Don't forget to multiply a. Here's what they mean. What we're going to do is to form this as a perfect square trinomial, we need to remove this negative 9 here. But in order to take it outside of the brackets like we want to do, we must multiply by 5, because technically 5 is being multiplied to all of these terms here. So I'm going to multiply negative 9 times 5 and put that on the outside here. Here's what it's going to look like. Y is equal to 5x squared minus 6x plus 9. We're going to close the bracket because we're removing out that negative 9. It's going to become 5 times negative 9, which is negative 45. And then we're going to go plus 7. Okay. Now from here, we can actually simplify this just a tad. So we're going to write y is equal to 5x squared minus 6x plus 9. And then on the outside, negative 45 plus 7, this is the same as saying negative 38. Awesome. All right, now we're going to go to our next step here. The 3 terms in the bracket make a perfect square trinomial. Write it as the square of the binomial, and then add the 2 constant terms together. Now, with these ones, what we did is we actually added the constant term in the previous section, so we've taken care of that. It's negative 38. To make this a perfect square trinomial, we could take this inner brackets and factor it like we did in Unit 0 or Chapter 0, but what we do know about this is the following. If it ends up being a perfect square trinomial, you know how we actually know what the term of that perfect square trinomial is? I want you to scroll back up. It is the b divided by 2 value. This is the common factor that makes it a perfect square trinomial. Here's what I mean by that. Right below, I want you to write the following. Y is equal to 5 multiplied, instead of this x squared minus 6x plus 9, if it's a perfect square trinomial, it's going to be x minus 3 all squared minus 38. Now you must be thinking like, wait a minute, how did you know it was negative here? If it's negative in the middle, or if it's negative after the b value here, or I should say before the b value, it will be a negative in the bracket or in the perfect square trinomial. And if you don't believe me that this is the actual factors for this, x minus 3 times x minus 3, just re-expand it out and prove it. All right, lastly, you now have the equation in the given form or in the given vertex form that we are looking for. Is that true? Of course it is. In fact, we're just going to rewrite it down here. I'm going to take this and go y is equal to 5 x minus 3 all squared minus 38, done. Perfect, there we go. Because we have our a value, our p value, and our q value. Or we have the p and the q that represent the vertex, the vertical stretch, which is represented by a. Excellent. So now we've seen an example about how we can put all these steps together to actually go from something that is a trinomial in general form or a quadratic in general form, and we can now use a bunch of steps that put us down into vertex form. And again, these mean the same quadratic. It's not like all of a sudden we're changing the quadratic and the function is going to be different and the graph will look different. That's not true. The graph will still look the same. It's just a different way of seeing it. And this actually allows us to do a little bit more application, which we'll actually see. And there's some economic problems and some different problems that are going to come up that are actually quite nice using this method. Now, let's get lots of practice with this before we actually go into the application. Converting from vertex or converting to vertex using the completing the square method. Now, some of these are going to be quite easy. Other ones might be a little more difficult. Let's try out the first one here. All right, so we look at A, and first and foremost, step number one, we want to group our first two terms. So I'm going to group x squared and positive 10x together. Close the bracket, leave 28 on the outside. From here, I'm going to see if there is a term in front of x, I'm going to remove it. In this case, there's 1. And 1 is a common factor between 10 and 1, but technically, if I just put 1 here, it's not going to change anything. So no greatest common factor to remove out. Step number 2, we're going to take the b and divide it by 2 and square it, and that will be our replacement term. And you'll see what I mean by that in a second. B divided by 2, all squared, is equal to, our b value is 10, divided by 2, all squared, which is equal to 5 squared, which is equal to 25. There's a reason I'm being very detailed on these steps, and you're going to see why. Again, in your notes, highlight the positive 5. Please make sure you highlight that because it comes up later, and we're going to see this pattern lots. Now, we're going to use that 25 to replace the following. It's going to be y is equal to, instead of it just being x squared plus 10x, it's going to be x squared plus 10x plus 25 minus 25, bracket plus 28 on the outside. Now, as you can see, these two, if I was to re-add them, just equal to 0. So technically, I haven't changed the inside of the brackets. I've just done temporary substitution. I'm going to take this 25 out of the brackets by multiplying it by 1. And if it gets multiplied by 1, it's just the same thing. So here's what it's going to look like. Y is equal to, on the inside of the brackets, x squared plus 10x plus 25, because I'm going to leave the positive term in. I'm going to remove the 25 and keep it with the 28 positive on the outside. Now what I'm going to do is, therefore, I'm going to put this all together. It's y where it's equal to, and let me just clean this up just a tad, y is equal to, in the perfect square trinomial, I could factor this just like I said before, but I know that it's going to be x plus, because there's a positive for the b value. That's how we know the sign that goes in between. Where do we find the number? The number is the b divided by 2 number. So anytime we have the b divided by 2 number, we're going to highlight that. I'm going to put that in here as 5, square it, and on the outside, it's negative 25 plus 28, which is positive 3. Done. There's my answer. So I'm going to make sure I highlight this nice and neatly, and there's our solution. All right, let's go on to B and do the exact same method here. So we're going to go over here, and instead of the previous example, now we actually have a common factor. So what we need to do is we need to rewrite this as y is equal to negative 2x squared plus 20x. Now we're going to put these in brackets, the x squared and the x term. I'm going to see if I can remove a common factor. In this case, I can. I'm going to remove out the negative 2 or divide both terms by negative 2. When I do that, I'm left with x squared. 20 divided by negative 2 is negative 10x. And then I'm going to close my bracket. Now here's where I go to my b divided by 2 step. B divided by 2, this is equal, and I should square it, sorry. B divided by 2 squared, which is the equivalent of negative 10 over 2 all squared, is equal to negative 5 squared, which is equal to 25. Now, again, whenever you divide that b value in half, please highlight that number before you square it, because it is directly involved in the end solution. So it's actually giving away a part of the answer here. Now we're going to continue below. I'm going to rewrite the quadratic function using negative 2x squared minus 10x plus 25. We always put the positive one first. Let me clean that up a bit. I'm going to put the positive, then the negative, bracket. Now, in order to remove this 25 outside of the brackets, because we don't want this negative 25 here, we want to only keep these first 3. To remove this, I must multiply by the first term here, or the coefficient term. So let's actually do that in our next step. Y is equal to negative 2 x squared minus 10x plus 25. And then if I take negative 25 and I multiply it to negative 2, this is going to make positive 50 on the outside. Now from here, we can simplify our final solution and say, therefore, the y is equal to negative 2, which was the greatest common factor. We're going to write it as x minus 5 all squared. Again, where did we get that negative from? Not only was it the b values term right here, but as well, the negative 5 was from here. So we always know from the b divided by 2 what it should be. And then on the very outside, it's going to be plus 50. Excellent. Highlight and make sure we save that solution. Okay, we're starting to see a pattern, right? It repeats, and between these two examples, look at how close they look in terms of their overall solution. It's only once we start getting to like fraction values or things like that, it might get a little more difficult, but in the case of these, I think you should start seeing a pattern now. Now, let's go down to this one here, C. We're going to do the exact same steps. So we're going to start by just going y is equal to 3x squared minus 12x. We're going to bracket the first two terms and keep the constant term on the outside. I'm then going to remove a common factor, which in this case is 3, leaving me with negative 12 divided by 3 is 4, minus 9. Here's where we do our b divided by 2. Our b divided by 2, in this case, I'm just going to jump right, no, I'll actually write this in here. B divided by 2 all squared is equal to negative 4 over 2 squared. Make sure that you're writing the negatives. If there is a negative on this term here, it better follow it. This is equal to negative 4 over 2, which is negative 2 all squared, which is equal to 4. Now again, as soon as you take your b divided by 2, highlight it. Now continuing this solution, we're going to plug in this positive 4. It's going to be y is equal to 3x squared minus 4x plus 4 minus 4 bracket on the outside minus 9, which was the constant. I now want to take this negative 4 and bring it outside, but before I do that, I must combine it with the 3. 3 times negative 4 is negative 12, so this becomes y is equal to 3x squared minus 4x plus 4. Close the bracket. 3 times negative 4 was negative 12 as mentioned. And then now, once we combine our constants together to finish the solution, it's going to be y is equal to 3x. And then how did we determine what was the solution here? It was our b divided by 2, or the negative 2, all squared. Negative 12 minus 9, negative 21. Let's highlight that solution. Perfect. Okay, let's go over to D. Now, with D, very, very similar. What we're going to have to do very first, though, is rearrange the terms. Because remember, if they're out of order, we want to make them descending. So it's going to be y is equal to negative 2x squared minus 16x minus 35. We're going to group our first two terms. Y is equal to negative 2x squared, all in the bracket, minus 16x, close the bracket, negative 35. And let me just make that as neat as possible. I know sometimes I can make these a little messy. Now I'm going to take out the common factor. I want to leave x squared alone as is. So what we're going to have to do is take out a negative 2, which leaves me with x squared. 16 divided by 2, well, negative 16 divided by negative 2 is positive 16, not positive 16, but positive 8x, close the bracket, minus 35. Now from here, what we're going to do is take the b value, divide it by 2, and square it. This is going to be equal to 8 divided by 2, all squared, which is equivalent of 4 squared, which is equal to 16. Now from here, we're going to plug that in for that third term. So it's going to be negative 2 on the outside, x squared. We're going to have positive 8x plus 16 minus 16, close the bracket, subtract 35. Okay, now from here, what we need to do is, in order to remove the negative 16, we must multiply it by the 2. Therefore, what I'm going to have is y is equal to, and make sure this is neater, y is equal to negative 2 x squared plus 8x plus 16, close the bracket. Negative 2 times negative 16 is equal to positive 32 minus the 35, which is on the outside. Now we wrap up the solution by saying, therefore, y is equal to the negative 2x. And then we got to look at what our b divided by 2 term was. It was 4. We're going to highlight that. So therefore, this becomes positive 4 in the bracket, and then squared. And then 32 minus 35, this is negative 3. There's your overall function. Highlight it and we are good. All right, let's go down to part E here. So now we're going to involve some fractions, and I know this might look a little more difficult, but even if you have to use your calculator to help you with these fractions, just use it. It will be the best way. So what we're going to do is we're going to group our first two terms. Y is equal to 1/4, and I should make sure I have a bracket here, x squared plus 2x, close the bracket, minus the constant term on the outside. I'm going to then remove 1/4 or divide by 1/4. When I take a number and I divide it by a fraction like this, like 1/4, it's going to leave me with just the x squared. And then what I'm actually doing is if you divide by a fraction, you're actually multiplying by whatever's in the denominator. So it's going to be 2 times 4. This is going to give me positive 8x here. Close the bracket, minus 5. Now we're going to do our b divided by 2. So b divided by 2 all squared. This is equal to 8 divided by 2 all squared, which is equal to 4 squared, which is equal to 16. Okay, now we're going to do this in the following order. Y is equal to 1/4 x squared plus 8x. I'm going to put positive 16 first, like normal, then the negative, and close the bracket, put minus 5. Now, again, in order to remove this fourth term here, I must combine it with the front term and multiply it. Negative 16 times 1/4, this is the same as saying I'm going to divide by 4 because it's 16 divided by 4 or negative 16 divided by 4. So we can rewrite this as y is equal to 1/4 x squared plus 8x plus 16 bracket. We're going to go minus 5, but first maybe we'll do the minus 4 because that's what we're removing. Now we want to summarize our final answer is therefore y is equal to 1/4. If this is a perfect square trinomial, we could factor it, just like I said, in the first unit, we've developed the skills for that, but we actually know what the factor is. It's going to be x plus 4 all squared, with -4 and -5 combining to make -9 on the outside. Now, if you're skeptical about that, where did I get that positive 4 from in the internal bracket to make up the binomial? Remember, it is always our b divided by 2. Always, always, always. So this is why I recommend writing out b divided by 2 and then actually representing that value instead of just jumping from 8/2 to 16. I want you to show this, because if you show actually what b divided by 2 is, it gives away the final solution here for the perfect square trinomial. Okay, let's go over to f. So f looks a little complex because we're like, wait a minute, 3y. We've never dealt with a multiple of y before. Let's divide both sides by 3. We're going to take this side divided by 3, and we're going to take all of this and divide it by 3. Now, here's what we get when we divide everything by 3. Y is equal to 1/3 x squared. 1/2 divided by 3 is the same as positive 1/6 because the 2 and the 3 end up multiplying in the denominator. This is going to be x plus 4. Now what we're going to do is group our first two terms. So it's going to be y is equal to 1/3 x squared. I should make sure I group that first one, plus 1/6x. Close the bracket, write the constant on the outside. I'm going to remove the GCF, which in this case is 1/3. When I divide these both by 1/3, it's going to leave me with x squared. If I divide this by 3, if I take 1/6 in my calculator and divide it by 1/3, this is the same as going 3 divided by 6, which actually just ends up giving us 1/2 x. Close the bracket, plus 4. And just to annotate that here, I'm going to make sure I do that because realistically, I don't want anybody getting lost on this step, especially with fractions. They're pretty difficult. So I'm going to arrow in here and just say this comes from when I take 1/6 and I divide it by 1/3 to remove out the greatest common factor. This is going to be actually equal to 1/6 multiplied by 3/1, which is actually equal to 3/6, which is then equal to 1/2. Just to show how we get that, because that could be easily overlooked. Okay, we're going to continue our work here. So now below, I'm going to go y is equal to, and actually we're at the b divided by 2 step. So I'm going to go b divided by 2 all squared is equal to 1/2 divided by 2 all squared, which then is equal to, if I have 1/2 divided by 2, this is the same as saying that we have 1/4. So in our bracket, I'm going to go 1/4 all squared. And when I square this, it's going to be 1/16. Excellent. Now, I wonder if there's any room to move this. Yeah, I'm just going to move this just a little bit over so that it doesn't intercept with our work, because obviously I don't want that getting in the way. So I'll just shuffle it a little bit off to the side there. Perfect. Okay, now we're going to continue our solution here. So the b divided by 2 is 1 over 16. Therefore, our new function will be y is equal to the 1/3 on the outside, x squared, which was our next term, plus 1/2 x. And then now we need our plus minus, plus 1 over 16 minus 1 over 16. And then on the outside, it was positive 4. Okay, now from here, remember, if we want to combine these, we have to take the negative 1/16, multiply it to 1/3. When we do this, here's what we're going to get. It's going to be y is equal to 1 over 3 x squared plus 1 over 2x plus 1 over 16, because the positive will stay inside. The negative 1, negative 1/16 times 1/3, this is equal to negative 1 over 48. And now, if we have 4 of these in our calculator here, we could actually just do this off to the side. If I take negative 48 and I multiply this, or I add to 4, sorry, negative 1 over 48 plus 4, we know that we could generate a common denominator here. So realistically, we could multiply 4 top and bottom by 48, and this would give us the number we placed there. Or we could just take this and add it into our calculator either way. So I'm going to go math frac, and I'm actually going to clear this just to make sure. We have this negative 1 divided by the, let's just make sure we actually have the value here, 48, because we multiplied it by that 4, or multiplied it by the 3 out front. And then from here, we're going to add 4. This gives me the following. I'm going to go math, frac, enter, and this will be my fraction. So 191 over 48. So I'm going to go to my next step and summarize it all together here. Therefore, we have y, which is equal to 1/3 x squared plus 1/2 x, and not plus 1/2 x. We actually want to do our perfect square trinomial at this point. Remember that the 1 over 4 represents the value that we're going to plug in there. So now, instead of it being the perfect square trinomial, we can write this as x plus 1 over 4 all squared, and then minus on the outside, or in this case, my bad, plus, let's pull open our calculator again, 191 over 48. There we go. And there represents our final answer, all here together. So as you can see, fractions might be a little more annoying, but they follow the exact same process. So we just need to be aware of that. The other thing I want to double check with is it's very easy to make mistakes on here. So if you notice a mistake, please mention it. This is one of those things where it's like you'll be working on these problems and you'll probably do a bunch of them and then realize, oh, wow, I might have made like little mistakes here and there. So just try to be as accurate as possible with your work. With these types, more than anything, with the fractional types, they're very difficult. Like the ranking of these is generally more difficult. So hopefully you have some good luck with these ones. Definitely practice at least a couple of them, and then work with fractions a lot, because the general numeracy ones or the general integer value ones are a little easier. These ones are just a touch trickier. All right, so to solve example 2, we're going to go into where we start dealing with revenue problems, and this is an economics problem, so I really like it. You would sometimes see this if you ever take any econ courses in the future. These are very, very popular questions where they deal with maximizing or minimizing revenue, so these are nice. Okay, let's read through it. A sports goods store is selling reusable sports bottles for $8, and at that price, they sell about 100 of these bottles. Research says that for every $2 increase in the price, the manager can expect to sell 20 fewer less bottles. Write the quadratic function that represents the revenue of this. Okay, so for any sort of revenue equation, what we're going to do is we're going to say that the revenue is equal to the price times the quantity. So however much we sell it for, multiplied by how many units of that we sell. Now for this one, they specifically tell us we are going to have the following. It was originally $8, but then market research says if we increase the price by $2, we're going to sell 20 fewer. So what we're going to do is write it as positive 2x, and I'll explain what that x means in just a second. We're going to deal with the quantity. They sell 100 units originally at that $8 price. That was the benchmark. But they say for every $2 increase there is, we're going to subtract away 20 more bottles. Now, what does X mean in this situation? It's the amount of price increases that take place. So X is the number of price increases. And ultimately, we know that if X is the number of price increases, then if we increase the price, we'll see that there is a drop in 20 bottles like this. So that's the important connection here that we're going to see in the very end that will help us establish what the proper price and quantity are that will maximize the revenue. Okay, now you probably see this from a mile away. We're going to expand this out because when we expand this, what it's going to allow us to do is build out a quadratic function. So I'm going to write this as 8 times 100, which is 800. 8 times negative 20 is negative 160x, plus 2 times 100 is 200x. Lastly, 2x times negative 20, this is negative 40x squared. Now, we don't want to stop there, right? We want to collect our like terms and reorganize it in descending order. So therefore, we're going to write this as negative 40x squared. 200 minus 160 is plus 40x, and then plus 800 on the very end. And what I'm going to do moving forward is I'm going to short form revenue is just R. So as we look down to here, this is going to be our overall function for revenue, where we have negative 40x squared plus 40. All right, now the point of the lesson wasn't to get into general form. In fact, we're going to deal with general form in the future lessons. What we now want to do is make this into the vertex equation or vertex form. So algebraically determine the maximum revenue the manager can expect based on these estimates, where for a $2 increase, it results in a $20 bottle loss. What price will result in this maximum revenue? All right, this will come directly off our vertex form, and you're going to see why in a second. I'm going to take this revenue statement, write it out again. Revenue is equal to negative 40 x squared plus 40x, and then plus 800 on the end. Now, what we're going to do is we're going to group our first two terms. So revenue is equal to bracket negative 40 x squared plus 40x, close the bracket, plus 800. From here, we're then going to remove a common factor. Revenue is equal to negative 40 x squared. If I take 40 and divide it by negative 40, this is negative 1x. Close the bracket, plus 800. Now what we want to do is our b divided by 2 squared term. So it's going to be b divided by 2 all squared, which is equal to negative 1 divided by 2 all squared, which is equal to 1 over 4. Perfect. Now again, when we take our b divided by 2 term, we want to highlight this because it actually indicates something very specific about the solution. All right, now in the end here, what we're going to do, or not in the end, at this step, what we're going to do is plug in this b divided by 2 squared term. So it's going to be revenue is equal to the negative 40 on the outside, x squared minus 1x plus 1 over 4 minus 1 over 4, close the bracket, plus 800. In order to remove this term on the outside, to move this term over to, with the 800, I'm going to have to take the negative 1/4 and multiply it to the negative 40 to remove it from the brackets. So now we're going to get revenue is equal to negative 40 x squared minus 1x plus 1 over 4. We're going to close the bracket. And if we take this of negative 1/4 and multiply it to negative 40, negative times negative is a positive. 40 divided by 4 is 10. So this is going to become positive 10 plus 80. All right, now here's where we wrap up our equation. The revenue is equal to negative 40 bracket x. We go to our highlighted term of negative 1/2, or the b divided by 2. So this is going to be negative 1/2 squared. And then on the outside, it's plus. And instead of 880, I should say 800, which makes the revenue 810. Okay, let's highlight something right away. On this terminology here, when we get this Q value, the Q value is always representative of the maximum Y value, or the general maximum. So what we're going to do right below here is say, therefore, in part of this solution, there's our equation. But on top of this, we need to do two things. First and foremost, the $810 is the maximum revenue we can expect. Which is the Q value. Remember, anytime we have that Q value, it always represents the maximum or the vertex in the situation. All right, for our next piece, dot, we need to figure out the price in which this occurs at, because they said if we make $810, how much were the bottles? Well, to do this, if we know that the price was equal to $8 plus 2 times whatever the X value is at that maximum price, well, what is the X value at this price? It's actually equal to the P value within the brackets here. So what we're going to do is we're going to plug that in. This is going to be equal to 8 plus 2 times the 1/2. There we go. And then close that bracket. This means that the price was equal to 8 plus 2 divided by 2. This is 8 plus 1, which is equal to $9. So each bottle was $9 and the maximum revenue was $810. And maybe I'll put that for here. The price is $9 for each bottle. Now, to be honest, if I was first learning this and if I looked at this, I'm like, where did this 1/2 come from? It was from the bracketed term here. The second question is, why did we not include the negative? Well, remember, the opposite is what we see. In the brackets, it's lying to us. If we have a negative here, we've actually shifted to the right. We have a horizontal translation that goes to the right by 1/2, meaning this is actually a positive value. And that's going to trip up a lot of you. I guarantee that is when you're doing these problems like this, you'll get -1/2 and be like, oh, I got to take that and plug it in for whatever my solution is. No, just take whatever this value is. If it's positive here, then we would put a negative. But in the case it's negative, it's lying to us. We have to put the opposite in the bracket there. That is representative of our p-value. Or the x value, which remember, we wrote a statement for this right at the top. The x value says it was the number of price increases. So technically, what did we do? We increased the price by $1 or a half of the amount that they said was in the market research. Okay, I'm going to make sure I highlight both of these as well because they are part of the solution. So the price is $9 per bottle and the maximum revenue is $810. Now, verify your solution graphically. Honestly, we can do this in class. We can do this together. If you have questions about this in tutorial, essentially what you would do is enter this function and then we can generate the appropriate graph for this. But in the cases of these types of problems, we're more concerned about the algebraic method than the graphing. If we wanted you to graph something, it would be a different context and it wouldn't be so applied like this. So please, if you want to verify this graphically, make sure you type in this function or even the original function we came up with in part A, which was this one here in general form. And then you could easily play around with that and see what the overall graph looks like. And we should get a vertex at the -1/2, or sorry, +1/2 and 810. All right, let's flip our page here. So example 3, we're now going to deal with a number problem. So rather than an economics problem, now it's more of a just standard math using maybe integer values to help us solve problems. Here's the outline of the problem. One number is 3 more than another number. Okay, let's break that down. One number, let x be the first number. And then what I'm going to do is say let, and I don't even need to say let again, the x plus 3 be the second number. There we go. So we've created a statement where we clearly understand what the first number is and the second number is. One number is 3 more than another, or the x is going to be less than the other number by 3. Find two numbers such that the difference between the square of the larger and twice the square of the smaller is a maximum number. Okay, this is pretty loaded. Let's break it down. So we want to figure out what is an output y such that the square of the larger, or x plus 3, all squared, minus is, and I just want to make sure I have this terminology good, the difference between these. Yes, the difference between the larger square and twice the smaller number is a maximum. Okay, here's our setup. So square of the first, and then twice the square. I should actually have a square on this other one here just to make sure. I'm going to underline these. This should be twice the square of this one, just to make sure we don't forget that there. Okay, we're going to expand this and then we're going to rearrange it because we want to make it in that general form so that we can convert it to vertex form. This is going to be y is equal to, remember, we do not distribute the square to both terms. We have to write it as x plus 3 and x plus 3. We write it out twice anytime we see a square. This is going to be negative 2x squared, so that one's quite simple. Now what we're going to do is when we expand this, we're going to get x squared plus 3x plus 3x plus 9 minus 2x squared. I'm going to then combine the terms I can. So in this case, I have x squared minus 2x squared, which is negative x squared here. 3x and 3x is positive 6x. And then there's only one constant term, which is 9. All right, Now, I'm going to explain why this negative makes sense, but I'm going to do that more towards the end. And I'm going to connect it back to some of the original language that was there. For now, let's just complete the square. So to complete the square, we're going to group the first two. Y is equal to negative x squared plus 6x, and we're going to put brackets around it. Positive 9 is going to go on the outside. Now, we don't want anything in front of this x squared term here, so let's move it out front of the bracket by dividing everything by negative 1. This is going to look like the following. Y is equal to negative x squared minus 6x, close the bracket, plus 9. Now we're going to continue the solution up above here, so I'll try to make this as neat as possible with an arrow. There we go. So we'll continue it here. The step we're on is the b divided by 2. So I'm going to go b divided by 2 all squared is equal to, well, in our problem, our b value is negative 6. So we're going to put in the bracket negative 6 divided by 2 all squared. This is the same as saying negative 3 all squared, which is equal to 9. Again, highlight that value right away. This is really important. Now from here, we're going to look at this and say, well, once we have our number, we can write this as y is equal to negative on the outside, x squared minus 6x plus 9 minus 9. And then our constant term that existed on the outside was actually positive 9, which is nice. Now to remove the negative 9, that's the fourth term, we have to multiply it by the constant, or multiply by the coefficient. Negative 9 times negative 1. This is going to give us positive 9 on the outside. Y is equal to negative x squared minus 6x plus 9 bracket, and then negative times the negative gives us positive 9 plus 9. We're going to now convert this and say y is equal to negative x, and then how do we determine the term? Remember, it's that one that's the b divided by 2. So instead of it being the x squared minus 6x plus 9, if we factored it, we would get x minus 3 all squared, and then on the outside 18. Now, this all has very, very specific meaning here. Let's pull this apart here. First and foremost, this negative 3, and I'm going to highlight it using maybe yellow, this negative 3, when we look in the brackets, it's actually the opposite of what we see. If it's negative, it's actually positive. So therefore, we know the first number is actually 3 because x equals 3. At the maximum point, x equals 3. The second number is x plus 3, which, what is x plus 3? That's 3 plus 3, which is equal to 6. And then they said that if we take the squares, or if we do that specific format, it would result in a difference of this form. Well, in this case, let's just actually go back to the context of this and review what this 18 is, or what our maximum is. They said that the maximum of this difference, or if we take the difference of these two numbers, the maximum difference we could expect would be the Q value, aka the 18 is the maximum difference we could expect here. So I'm going to go down here and say the maximum difference is 18. So maximum or minimum, depending on which problem it is, it will always be this outside number, or the Q value, which represents this constant term that is kind of on the outside that is not connected to the x here. All right, and then this would all come together to make our solution. First number is 3, second number is x plus 3 equals 6. Maximum difference between those two that could exist is 18. Now, if you want to algebraically prove this, all you would do is just plug in the 3 and the 6 back to this original equation here, and you would simply get that the y is equal to 18, or that maximum difference was 18. Now, something to be aware of, please be very clear with your two numbers in terms of their just generic form. So define them in the original statement, because this made it really easy to connect them to the answer at the end and be like, if I have an x, then what is that? It's the first number. If I have an x plus 3, that is the second number, and it kept it really easy for us. All right, so now we're going to go into the area and perimeter problems. And for these ones, often what they're going to get us to do is relate the idea that we have perimeter and area that can be used interchangeably together to help us establish an equation such that we could figure out the largest or minimum area depending on the circumstance. So for this problem, what they want us to do is take a garden plot and divide it into 3 equal sections using a fencing total of 100 meters. Now, what is the largest area, or what dimensions will enclose the largest area? Solve it algebraically. So first and foremost, let's use a visual off to the side here. I'm going to divide this into 3 equal sections, or as best as possible. Maybe that's not the best, so I'm going to erase these. I'm going to try and be a little more accurate here. So there's 1, there's 2, there's 3. Perfect. So those are pretty good. Now, when we look at these, this is going to be one width, this is another width, this is another width, this is another width. Because technically, these are all going to be included with fencing. Fencing has to run along all these widths. We also have a long length here and a long length here. Now, here's where we go into the overall maximum area that we could potentially construct here and how we relate it to the perimeter. We need 2 equations in order to help us establish this overall quadratic. First and foremost, perimeter is equal to 2 times the length plus 4 times the width, because there is 4 widths that split this into those equal 3 areas and 2 lengths that run along the long sides. Now, the area of this, so we're going to say area is equal to, well, we know it's just simply the length times width, because realistically, we want the area of the entire garden plot. So we don't care about the fencing within the middle. We just want to figure out what is this total area that is all being enclosed completely. Okay, now something important here is that not only was the perimeter equal to 2 lengths and 4 widths, but they actually told us that we had 100 meters of material to work with. So I'm going to say that 2 lengths plus 4 widths equals 100. Now, what we're going to have to do is we're going to have to isolate for one of these variables, or else we won't be able to solve for that maximum area that we're looking for. So step number 1 was to generate our 2 equations of perimeter and area. Step number 2, I'm going to take that perimeter, which is 100, which is equal to 2 lengths and 4 widths, and I'm going to isolate for a variable. We could choose either one. Honestly, it could be length or width. I'm going to choose length. We're going to minus 4w from both sides. When we minus 4w from both sides, this is going to give us 100, which is minusing 4w, or 4 widths, is equal to 2 lengths. Then we're going to divide both sides all by the 2, or divide all the terms by 2. When we do this, we're going to get that the length is equal to 50 minus the 2w. All right, now this is helping us do substitution, which is a 10C skill. Once we have this length, we can take this and plot it or plug it into our area equation, and this will help us build a quadratic function. So let's actually do that starting at step 3. We know that the area, again, just to rephrase the equation, area of this overall rectangle is length times width. In the case of knowing the length, it's going to be 50 minus 2w, all multiplied by the w on the outside, or the width. We're then going to carry this forward and say it's equal to 50w, because 50 gets multiplied to the w. Negative 2w times w is negative 2w squared. Now, we're not satisfied with this order. When we have it as 50w minus 2w, this is in ascending order. We want it in descending order, so I'm just going to restructure this as negative 2w squared and then plus 50w. Okay, now I can give you a heads up. Anytime you see a negative, this means the overall quadratic faces down. Therefore, there is a maximum. So this is a good confirmation for us that we're doing the right thing right away. Let's continue this. Okay, we're going to group the first 2 terms. Negative 2w squared plus 50w. We put it in brackets. Step number 2, we want to make sure we remove the greatest common factor and leave the w squared, or whatever that variable is, alone as its variable. So w squared, 50 divided by negative 2 is negative 25. And this is going to be a w on here. Now what we want to do is take the b divided by 2. So I'm going to go b divided by 2 and square it. In this case, it is negative 25 divided by 2 all squared. Well, negative 25 divided by 2, just to make sure we have this right here, we took out a 2, divided it, awesome, perfect. This is going to be the following. We say when we divide 25 by 2, I'm actually going to keep it exactly as these numbers. And so because 25 and 2, they're not going to evenly divide. 2 is a prime number in this case. We're going to go 25 squared, which will give us, and I should make sure that's cleared out, 25 squared is 625. So I have 625 in the numerator, and then this is all divided by the 4 in the denominator here. Okay, so this is our b divided by 2 term. Again, when you divide it by 2, what I would do is make sure that you have it highlighted, because this will come up later down the road. Important term. Okay, and now once we have our 625 over 4, we're going to take that up above and we're going to plug that into the quadratic function. So I'm just going to go up above, I'm going to try to zoom out and then go up into this upper area here. We're going to write that area is equal to, the first piece was -2, we then had w squared minus 25w, and then this piece here we're going to plus and minus is 625 over 4. So plus 625 over 4 minus 625 over 4, because remember we have to do the plus minus of that exact same b over 2 squared. Close the bracket. Now, in order to remove this 625 over 4 out on the outside, we have to multiply it to the 2 that it's out front, or the -2. This is going to give us area is equal to -2 w squared minus 25w plus the 625 over 4, close the bracket, and then on the outside, this is going to be 625 over 2. If we do this 625 over 4 times 2, it's going to go 2 over 4, which is 1/2. So we go plus 625 over 2. Excellent. Now we want to summarize this as the following. A is equal to -2. In the bracket, it's going to be W. We go back to our B divided by 2 squared term. Or it was -25 over 2. I'm going to plug that in here as -25 divided by 2, square all of this. And then on the outside, it was 625 divided by 2. Now what I'm going to do is I'm just going to actually get some specific values for these. So instead of 25 over 2 and 625 over 2, let's just plug these into our calculator just to make sure. So we're going to go area is equal to, and we're just going to rewrite this using the closest decimals here. First and foremost, when we take 25 and divide it by 2, we get 12.5. So this is going to become -12.5 all squared. And then 625 divided by 2, this is going to give us 312.5. Excellent. Okay, now we have to pick this apart here. So here's what this actually means. Therefore, and we could even have wrote the therefore here starting at the equation. We're going to write a couple bullet points with this. The width, or the W, is equal to, and I'm actually going to use a full sentence here. So the width is 12.5. And just to be specific, I want to make sure that if there was any units we're putting it, yeah, it's meters. So 12.5 meters. We know that the maximum area is always the Q value. And in this case, that's the 312.5 meters. And then just to make sure that we're not missing that they asked for the length, I think they said find the dimensions. So we want both dimensions, the width and the length. What I'm going to do is I'm just going to move down this max. Actually, no, I can leave it there. That's okay. I'm going to put a dot and say we know that the length was defined by, if we go off to the side here, by the perimeter equation, length equals 50 minus 2w. So I'm going to go 50 minus 2 times the 12.5 and then close it. This is the same as saying 50 minus 25, which is the same as saying the length is, and I'll make sure I put a sentence form here, 25 meters. There we go. So these are the dimensions. The width is 12.5, the length is 25, and then the maximum possible area that can be generated is 312.5 meters. Okay, now here's where you're going to want to go onto the assignment and try as many of these as possible, because all of them are contextually just a little bit different, but in terms of the way they solve, they're all extremely similar. Once you have them set up, the square method is actually very regurgitative, in the sense of once you understand what you're doing and the steps, it's never going to change. It's not going to fluctuate in any way. It's just the contextual piece that is going to be the toughest to kind of grasp. And again, you have things like area problems, you have number problems, you even have things like revenue problems that like to shake it up in a little bit different ways, but the practice problems will get you to look at all of those cases. All right, good luck on the assignment.